Good afternoon, ladies and gentlemen. I hope you guys are doing well. You won't believe what this dude was doing before this. I'll have you know, I wasn't doing anything. I was watching someone. I was watching Redbird play some frickin' Honeycam Studio. And you're still doing that. You're still doing that. I see you in the fucking Discord server, still watching. Shaking my damn head, lazy. Anyway, so yesterday we got a little bit confused, or I got a little bit confused, I should say, about what the fuck this O-stream bullshit that we were dealing with was. I swear to God, if you guys are going to start fighting right here, go away. Bad kitties. I'm obviously watching this. I would never watch two streams at once. Shut the fuck up. Yes, you would. But anyways, I got confused as fuck by this O-stream bullshit, so let me open this folder real quick. We're going to go over to here. And it's going to be all like, oh no, what do you mean you didn't understand what the hell was going on? And I'm going to be like, of course I didn't understand what the fuck was going on. This shit was not explained. Okay, so real quick, we're just going to go ahead and do... I'm just going to go look at it. So, fucking, what I was... The main things that were confusing me, which I still don't understand, I don't know what this is for. I don't know why this friend thing is here. But when we got into here... what I understood is that this is essentially just printing out the text. I don't even know who this red bird is. Oh yeah, of course you don't. This text here, this O-stream operator STD O-stream out const player, this whole thing is basically just a big text string that that prints out our little bullshit. So if we do, I mean, I have to compile it again if I want to do this. Then we do like this. All right, so all it is, right? We're printing this out, and then it has the game, and then we put our game, and then the different names because we have first name and last name. All it's doing is printing this shit out. But what I suspect has happened is that this, what we've done here is kind of like what happened with the one definition rules chapter when we did that. Because way up, was it? Oh, where the fuck was it? It was this one. In functions. Fucking one definition rule. We started using classes and stuff, and none of that was ever explained, and I was like annoyed and confused by it. So I think that something similar has happened here, where this isn't necessary. He hasn't explained this. I don't really understand how this syntax works. So what I'm suspecting is that he's done the same thing again, where this isn't necessarily intended to be understood. All that was supposed to be understood is how inheritance works from one to the next, which is annoying because I was able to understand that much, but it didn't, because I can't parse the code, because I don't know how to read this. I was very annoyed and frustrated with a lot of the stuff we were doing yesterday. So I'm going to just kind of go with the flow and hope that he explains something or some of this stuff later on. Because, I mean, it seemed like all he wanted to do was make sure we understood inheritance, which I don't agree with that kind of... the way that is presented, but such is life, I guess. So we're going to go ahead and open the next folder. But I don't think we're going to hold off for a bit, and we're going to go ahead and get this this section underway. We're on protected members. This is at the 23-hour, 21-minute, and 10-second mark. Wow, we're only 8 hours from the end, and about 3 hours of those are... we got about 3 hours of classes left, so odds are we're not completing it this week, so we'll see. Anyways, take it away, Gakwaya-sensei.
In this lecture, we're going to learn about the protected access specifier you can use in your C++ class. And we're going to be reusing the same example from the last lecture. We're going to have a person class which is going to act as our base class, and we're going to be deriving from this person and creating a new class called player. The player class is going to have a person part baked in, and we can use this as a foundation to build other things in player class. For example, we can set up our own member variables and do all kinds of crazy things. And this is the setup we used in the last lecture. We set up a person class and our members were private, as you saw here. But in the last lecture, we saw that private member variables are not going to be accessible and usable from derived classes that do public inheritance. And sometimes we want members from the base class to at least be accessible and usable from a
Various
derived
greetings. Hope you're
class,
doing well. I'm
but
doing
still
well.
be inaccessible from the outside.
I hope you're doing
And we
well as
can
well,
achieve
Steve.
this using the protected access specifier. So for example, we can change the access specifier of our member variables from private to protected. And at the moment we do this, we will be able to access, for example, read from and write into these member variables from derived classes. So for example, we will be able to modify these guys from a constructor of the derived class. And we saw that that was impossible from the last lecture, but still we want to be able to use these from the outside of our derived class, which is person here. So we're going to still do public inheritance like from the last lecture, but now that our member variables in the base class are protected, we will have the ability to do whatever we want with them in the derived class. And when we say in the derived class, we mean from any method from the derived class. For example, we can go in our constructor here and then set data into the member variables from the
Your sleep
base
time's
class,
mutating again, so I may start seeing you at 4 a.m. again.
in a minute.
Nice.
Now that you know this, we're going to head over to Visual Studio
I,
Code and play with this
I
a
hope
little
it's
more.
not like
Okay,
unhealthy.
again, our member variables from the base class are going to be protected. Okay, so we can really say that here. Let's say protected. And at the moment we do this, they are going to be accessible and usable from a derived class. So from the derived class, we will have the first name, for example. So from the derived class, we will have our members baked in.
I have no idea how bad it feels.
The last name and the first name. And
sucks,
because
dude.
they are protected in the base class and we are doing public inheritance, we will be able, for example, to set data into these member variables from a derived class. And that's going to be really cool. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our...
I'm kind of... Maybe I talked over it or something, but it didn't seem like I did. At least I don't... but I'm not sure what... I'm not sure what exactly the difference between private and protected is. It's like... Alright, let's continue.
Here we are in our working folder. The current project is protected members. We're going to grab the code from the last lecture and reuse that because that's going to have our inheritance hierarchy already set up. We will have our person and player class, and we can reuse them. We will have our person and player classes, and we will reuse them without needing to completely set them up from scratch. That's going to save us a few seconds. So we're going to put them in here, and we are going to open this little guy in Visual Studio Code by dragging and dropping here, and we will have our person class, which is going to be the base class. It's going to have our member variables, which are going to be private from the last lecture. We will have our player class, which is going to be inheriting publicly from the player. We will have our player class, which is going to be publicly inheriting from person. And we have our main CPP file, which is going to set up a player object and try to use it. And we're going to see how this goes in this lecture. So what we want to do is to change the access specifier in the base class and make that protected. We can do that. We can say protected. And this is going to change a few things about this class. What this is going to do, if you do public inheritance from this person class, you will have the ability to do whatever you want with these member variables from a derived class. You will have the ability to write into the...
Protected is private outside the scope except for classes that inherit it. So So if I were to make something else called person, or if I was to use person in some other context, then these things are considered private. But if I were to do player, like if I'm using player, then it acts like it's public because player has inherited the person class. Is that kind of explained the way that it? Yes, I think so. Okay.
These member variables and change the data that we have inside, you will also have the ability to read from them. And that's something we couldn't do from the last lecture, and this may come in handy sometimes. Another thing you should know is that these members are still not going to be accessible from the outside. So from the standpoint of the main function, for example here, they are going to behave as if they are private because they won't be accessible from the outside. They will only be accessible and modifiable from derived classes that do public inheritance. This is really important to understand.
Okay.
Now that we have this, we can really do all kinds of crazy things. For example, we can go in our constructor of player and comment what wasn't working from the last lecture, and this is going to work now.
Oh wait, did I delete this from? Okay. So if I do first name equals John, and then last name equals Snow. So this didn't work before, but we're not getting our red squigglies, basically saying that it doesn't work.
So let's uncomment this, and we're going to see that the squiggly lines are going to go away. And if we build a player object using this constructor, we're going to see that we're going to have Jon Snow in, even if we don't set using the setters from the base class. So we can take these out. And if we print information about this player, we're going to see the game to be basketball. And the names are going to be Jon Snow because we are setting up this in the constructor of player. That's no longer going to be the data we get from the constructor of a person
That's important
object,
to know.
which was here in the base class. Let's try to build and run this program so that you can really see this. I just used Clang here, but it is also going to work. No big deal here. The build is going to be good. We can clear and bring up a PowerShell window we can use to run this program. We're going to say rooster, and you're going to see that player is going to be having the information. The game is going to be basketball. The names are going to be Jon Snow, and we are setting this data from a derived class. And we have the ability to do this because these members are now protected in the base class, so they are accessible and usable from a derived class. Now that we have this ability, we can really change how our class, at least the derived class, works. We're going to change it to have 2 more parameters, and we're going to pass the first name and the last name, and pass this data back into the base class by setting the data in the body of the constructor. This is going to work. So let's add our parameters. We're going to say std string view, and this is going to be first name param, and we're going to put in another one which is going to also be a string view parameter, and it's going to be last name param. We can say that, and we're going to hop over in our implementation. Let's grab what we just added because we will need to put that in our CPP file. We are going to go in player.cpp, and we're going to add this data. We're going to put that here. We can close the left sidebar to have some more breathing room. And then we're going to not do an initializer list here because this is really going to be useless. We are changing data in the body anyway, so what we can do is say game param or game, and we're going to say game param. I am really sorry, I am not following the same convention for the naming of my member variables, but we can change this later. So let's say first name, we are going to pass in first name param, and for the last name, we're going to say last name param, and that's going to do. Now we have the ability to go in the main CPP file and create player objects and specify the first name and the last name, and this is going to be much more flexible. So let's go back to the constructor and see the order of our parameters: game, first name.
Hold on. Okay. So we have our O-string thing. Kind of want to make this. Yeah. Okay. Holy. Okay. So this is kind of what this makes more sense to me than what we had before. Because this we like, okay, this is totally. I felt like there was stuff that was missing that we weren't adding, which I very much did not appreciate. So we're looking at this. We have our game parameter, our first name parameter, our last name parameter, all in the form of string view.
Name, last name. So we can come here and say first name is going to be John, and the last name is going to be Snow. And if we build and run, we're going to see the information printed out here. And now we have the flexibility to be able to specify this in a constructor. And this is going to make the job of building our objects much easier. And we can forward this data back into the base class using the protected mechanism that we just learned about in this lecture, and this is really cool. So let's build. We're going to pass this through GCC, and the build is going to be good. We can clear and run Rooster. We're going to see that the data is passed back to the base class, and this is working really well. Okay, so this is really all I wanted you to see in this lecture. We can set up protected member variables, and they are
so
going
it's definitely
to be
working
and
as intended
from
so
any
far.
Derived class that does public inheritance, but they want to be accessible from the outside. So if you try and, for example, say P1 and say first name and try to change that to something else, let's say Daniel, for example, you're going to have compiler errors because this is not going to work. So let's try and build and show you the compiler error. Okay, so protected members are not accessible from the outside. They will be just accessible from derived classes, or to be more specific, they are going to be accessible from the members of the derived class.
Inaccessible.
And by members, I mean member functions, because that's where you will be accessing and modifying stuff. So let's go back to the main CPP file and remove this. And this is really all I wanted to share with you, and I hope you found this lecture interesting.
I did.
We are going to stop here in this one, and in the next one we're going to zoom in on the syntax here we are using to derive from other classes. We just did public inheritance here, but in the next lecture we're going to see that it is possible to actually do protected and private inheritance. And we're going to see what this means.
That sounds interesting.
So go ahead and finish up here and meet me there.
Okay, so all of that stuff kind of makes sense to me. So this has our... If we look at our player thing, right, we have our game parameter, and then when we go into... We've created a constructor here that lets us do both the game and the first and last name, which before, if we wanted to do something like that, we needed to go through a setter, which kind of, it seems like it doesn't work. Oh, well, no, the setter should still change things, I think. Here, let me try. Let me go to terminal, run task. All right, so now we have John Slate. Yeah, so the setter still works. But we don't actually have to go through the setter to change things in our player object now, because we can just set the parameters. We can set some stuff up to make it so that it actually works so that we can construct essentially the whole thing, right? Like before, what we had, like when we had it just by at its default, you need the setter to edit midway. Yes, but you don't. We don't need the setter so that in order to like change the name, or in order to have our name be something other than the default. Because the way we had it set up before, we could only create a player object that had the default names that we put in person. But with the addition of these I guess of these parameters, we can introduce more arguments. I think it's still considered arguments. Jim Sleet sounds like Jon Snow's hooker name. Yeah, that's the way that I went. That's kind of what I was going for. Because it was like John, Jim, Snow, and Sleet. Hi there, Rag. Hello, Ivka. How you doing? How's learning going? The only thing that I'm annoyed with is this OStream thing that hasn't been explained. It was copied into the code, and it was never. He never went over it, and this particular thing doesn't seem to have been relevant. So I'm a little bit annoyed by that. But it's also not relevant to what he's trying to teach. So it's a little bit. It's mostly annoying that I can't parse all the code. Learned another song on guitar. Nice. Nice. Let's see. Is there anything else that I'm maybe? Yeah. It just lets you see out the whole class. When is RE2 going to be? Probably next week, to be honest. I think I'm going to try to play through like Tenchu or something, and then we'll go through the other story of B, the other story of RE2, probably sometime next week. I imagine it probably won't take nearly as long because it should be at least Claire B felt like it took way less time than Leon A. And maybe that's just me not knowing exactly what I'm doing, but still. All right. Anyways, let's continue with this section.
This lecture, we're going to learn about base class access specifiers. And in case you didn't know, we have been using base class access specifiers in this chapter all along. And to really understand this, let's look at our player class, which is inheriting from person, and we are doing public inheritance. The public keyword here is a base class access specifier, and it is going to control how accessible are base class members from a derived class. And we have three options. Okay, so if we do public inheritance like we see here in our player class, anything that is public in the base class is also going to be public. You see M1 here is also public in the derived class. Anything that is protected is going to stay protected. And anything that is private in the base class is also going to stay private in the derived class.
Claire A has mostly the same objectives as Claire B and items.
The member access specifiers we have in the base
I'm not
class
sure because I didn't play Claire A.
Stay intact if we do public inheritance. Again, anything that is public in base is going to be public in derived. Anything that is protected in base is going to be protected in derived. And anything that is private in base is going to be private in derived. This is one kind of inheritance we can do in C++.
Okay, so because he's going over this specifically, I think what I want to try and guess is what protected and private inheritance is going to do to the derived class. What I suspect is that protected will make anything that is protected or that is public become protected, and then privates will stay private, and then protecteds will stay the same. And then when we do inherit it as a private class or whatever the hell, when we do private person, everything will be protected or will be private. but in the inherited class. That's my guess. That's my guess, and because that is what logically makes sense to happen.
But we can also do protected inheritance. And the syntax to do that, you just use
Oh
the
yeah,
protected keyword here. You say class player, colon, colon, and specify that you want to do
I'm a
protected
freaking
inheritance.
genius.
And then you specify the base class you want to inherit from. The moment you do this, anything that is public in the base class is going to be protected in the derived class. Anything that is protected is going to stay protected. Anything that is private is going to be private. And in one way, you can see that we can use these base class access
Are you public
specifiers
player or are you
to
private gayer?
constrain the
I'm
access
private
specifier
pile.
in derived class. But we can't make the access specifiers in derived class more relaxed. We can
I'm
only
trying
make
to
things more
stay out of the
constrained or
way.
more restricted. For example, the M1 member variable was public, but now we have made it become protected by using the protected base access specifier here. Okay, so now you know that we can do public and protected inheritance, but it is also possible to do private inheritance.
Yep, and then
And
everything's
you do that
private.
by using a private base
Nice.
class access specifier. The moment you do this, anything that is public in the base class is going to become private in the derived class. Anything that is protected in the base class is going to become private in the derived class. And anything that is private is going to stay private in the derived class. And again, you see that this is going to constrain things. Things that were public are now private in derived, and we can't really do anything.
Is it you who made the VTuber avatar?
Any other class that might
yes.
derive from our player class.
It's like very default.
This is the setup we have. Okay,
it's like not quite default settings on in the character model creator that I use. I think it was Vroid Studio. I changed it a little bit so that it was not quite just one-to-one default guy, but it is still pretty close. I don't have any like custom assets or anything like that. I have wanted to do something like that, but I feel like a 2.0 debut would be a little that'd be like I don't know, maybe like 1,000 followers type goal. But I don't have that many people following me yet, so I'm not too concerned about it.
Sum this up, through the base class access specifier, we can control how relaxed or constrained is the access to base class members from the derived class. And this is really important to understand. If you want to say as relaxed as they are in the base class, you can use public inheritance. If you want to constrain a little bit, you can use protected inheritance, and things are going to be inherited as protected except for the private data in the base class. If you want things to be super constrained, you can use the private inheritance that we just learned about, and everything in your derived class is going to be private. And you can use this if it makes sense for the application you are designing. And you can use these kinds of features if they make sense for whatever application you are designing with C++. One thing you should know though is that regardless of the base class access specifier we use, private members of the base class can never be accessible from a derived class. So anything that is private is going to stay private, and you have no way to relax things a little bit. That's not going to work. You should
That's actually kind of an interesting thing to point out, because if you have from what the way I'm understanding this, if you have your base class, right? In this case, we use person. If we make this part private, like if we have multiple derivations from, like, let's say we go from person to player, and then from player we specify, like, I don't know, fucking basketball player, or like maybe we divide it into like different sports or whatever. Like the name is all, because the name here is part of the person class. No matter how many times we add things to we inherit classes, or inherit new classes, it will never be able to be like this will never be public unless we like specify it as public. It can only get more constrained. It cannot be less constrained in a newer in a inherited class. It's almost like it feels like it's only able to get more narrow in that way.
Really know this. Now that you know these kinds of inheritances we can do in C++, we're going to head over to the next lecture and play with them a little more. In this lecture, we're going to play with the base class access specifiers we learned about in the last lecture.
Base class
in other words, we're
access
going to play
specifiers.
with public, protected, and private inheritance in Visual Studio Code. So let's review a little bit what we talked about in the last lecture. We said that we can have public inheritance, and the syntax to do that is what you see here. And the moment you do this, what was public in the base class is going to be public in the derived class. What was protected is going to stay protected. What was private is going to become private in the derived class. In other words, public inheritance is really not going to change the accessibility of the member variables we have
public
in the
inheritance essentially copies the how it
the same access level we had in the base class.
Yeah, copies access level 1-to-1, I think.
Public inheritance in C++. We can also do protected inheritance, and what this is going to do is to make protected the highest access level we can have in the derived class. So anything that was public in the base class is going to become protected. Anything that was protected is going to stay protected because that's the highest level we can do now. And anything that was private in the base class is going to be private in the derived class. We say private in the sense that it is going to be private to the base class. So you can't really use M3 from the player class in this case. If you try to do that, you're going to get a compiler error. Okay, we can also do private inheritance, and the syntax to do that is what you see here. And now private is going to be the highest level we can do in the player class in terms of the members that we got from the base class. So anything that was public is going to become private. Anything that was protected is going to become private. Anything that was private to the base class is going to stay private to the base class. This is what we mean here. But now M1 and M2 just became public to the player class. If anybody else tries to derive or inherit from a player, these things are not going to be accessible. And this is in some way the player class being selfish. It is saying, I am going to get everything I can from my parent class or my base class, but I am going to make it all mine. Nobody else can take this. And this is the kind of setup
where have I heard that before?
With private inheritance. Okay, so now that we have this in mind, we're going to
private inheritance, more like
code.
No inheritance.
We're going to set up a bunch of classes. We're going to set up a person class we're going to be inheriting from. We are going to set up a nurse class, which is going to do protected inheritance. And we're going to set up an engineer class, which is going to do private inheritance. And we're going to really play with this and see how this plays out in real C++ code. So let's do this. Here we are in our working folder. The current project is base access specifier, a demo. We're going to do a demo on this, but before we do that, we're going to grab our template files and put them.
Okay, we're going to go ahead and make this smaller again. And then I'm going to go ahead and first, we'll save this, make sure all of this stuff is good, and then we'll open up our new project, which I'm assuming is what we want because he's opening up a new project.
Them in place. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us a good starting point. We're going to have our main CPP file. We're going to clean it up, and we're going to set up our base class, which is going to be the person class. So let's put this in from scratch. We're going to add our files. We're going to say person h, and we're going to say person.cpp. We are going to hop over in our header file and put in our code. Nothing special so far. We have an
oh god, it's the same. It's the same issues. It's the same stuff. Okay. This looks like it's some different stuff from before, so I'm not gonna bother trying to copy this stuff. If and person H, define person H, include string. For some reason I assumed it was the IO stream, but it's not. Class person. So we have friend. I don't know what this. I still don't understand what this friend stdio stream thing is. I kind of wish that he wouldn't have just started using it out of nowhere. So we have const person address person, because we're looking at some sort of reference, but I don't know what the fuck it is. All right. So then here we have our public. So person. We have our default constructor. Then we have our customized constructor, const std string address full name int age. So we're only doing our, so we have our full name thing. Oh, I'm an idiot. For some reason I didn't. Then we have const std string address. So I'm going to assume, alright, and then we have our destructor. There's a chance he just gets rid of the destructor at some point, because that's what happened last time. String get full name const return member full name. So we haven't defined a member full name yet, but we'll be doing that one shortly. And then from here we do our int get age, no parameters, and then it's a const return age, which we understand. And then there's the std string get address const return member address.
Include guard. We have our person class.
Okay, so then we have our return address. So it looks like we have multiple things that are public here. Curious why we would write public a second time. std string oh wow, it's all caps. Didn't mean to do that. std string member full name initializes as none. Boom, boom. And then we have a protected. That is our int. That is our age, which we will initialize at 0. And then private, which is a string that is also going to be initialized as none. None. And then we do this, whoops, this, and then end if. And we have person H here. Okay, so I think this is our include guard, I think is what he called it. Okay, so this is our person class. Just to double check.
Nothing special so far. We have an include guard. We have our person class.
Yeah, for some reason, I'm not quite sure why we have two things saying public here. Probably just for, I think what it is it's for readability, because these are our getters. We don't have any setters created yet. These are our constructor and destructors, or constructors and destructor. And then these are our member variables. So we just do this like, okay, this one is a public member variable, this one's a protected member variable, this one's private. Okay. I think I'm understanding the how and why we're doing certain things right now.
As it has a bunch of member variables, we have the full name, which is public, we have the age, which is protected, and we have the address, which is private to this class here. This is going to be our starting point. We also have a bunch of constructors. We have a default one. We also have another one which is going to take all the data we can use to construct a person object. And here we are passing a const string by reference. I think we can fix this and pass a string view. This is going to be better. Let's say string view. And we're going to change the first parameter here to be an std string view by value. This is going to be much better.
String view.
Okay, we have our class. We can hop over in the CPP file and put in our implementation.
Okay, so this is how the class will be implemented. So here we include person.h, and we include IOStream. So here we have person in the scope of person. Const std string address full name int age, and we have const std string address member full name member age and member address as address. And then we have this. I don't understand why that is like that, but it is, so I'm not going to question it. And then we have this OStream thing again, which I'm not going to question. I'm just going to copy it because it hasn't been explained and I don't understand it, and I don't like that I don't understand it. But my attempts to... I would like it to be explained in the video by... because we haven't... God. I will never not be frustrated by it, I don't think. Out. Person. Full name. I'm curious why it's done this way. Then we have person.get full name. So this is our getter. We're going to do age person.get age, and then address person.get address. And return out. So, God. Cool. So the way we have this, I should make this OStream, not OStream. Const person, address person. So here we're printing out some text that says person full name, and then it gets their full name, which is our getter in here. So we get full name, and it outputs a string. So this is our method for getting a full name. Then we have our get age. It's another method that we created, get age. And the same for get address, which is also used here. And all it's going to do is output the information that we give it. So this says, okay, well, he's got a red line underneath it as well, so he's probably got to change something. In any case, we'll go to this person, destructor person, and then we do boom, like so.
Are going to change the constructor a little bit and make sure we are taking an std string view by value. And if you want to type all this code, you can get it from the resource section of this lecture. I am going to attach all the source code, and you can download and use this however you want to really make your learning experience as pleasant as possible. So we have,
well, I copied it all in by hand, so
into our member variables. The full name is going to go into our full name member variable. We're going to grab the age and the address, and we're going to store all this information. We also have an output stream operator, which is going to be printing all this information here. It is going to go through the getters because we have a person object passed as a parameter here, and this is going to work. We can go in the main CPP file and include our person class and create an object of it. We can do something like person1, and we can pass the data that our constructor expects. We can pass in the full name, the age, and the address. So let's do that. We're going to say the full name, Daniel Gray, why not? And the age is going to be 27. We can put in whatever we want. And we're going to put in the address. We're going to say Blue Sky Street. We can say 233, for example, and say the number of the house to be 56. Why not? This is a possible address for a person. So we can say person1, or we can use stdc out to print this out because we have an output stream operator for our person class. We can do this. We're going to say person1, and we're going to put him out. And if we build and run this program, we're going to see that this is going to work, hopefully. And we have a problem because we don't have a semicolon at the end of line 6 here. Let's fix that. We're going to run this task to build with GCC. The build is going to be good. We can bring up a PowerShell window, and we're going to use this to run our program. If we say rooster, we're going to see that we have the person printed down. The full name is Daniel Gray. The age is 20.
Look at that. Full name, Daniel Gray, age 27, address, Blue Sky Street, 233, number 56. And all of that is because of this thing. I mean, it's the whole thing, really, but, like, this is the thing that lets us print it out. This is how you print me out. I'm still annoyed that whatever. All right. In any case, so we have our person class constructed. We have our that whole thing done.
27. The address is Blue Sky Street 233, and the number of the house is 56. So this is a possible implementation for the person class, but we are really not interested in setting up a person class and doing things with it. We are interested in inheriting from the person class and learn about different kinds of base class access specifiers we can do. So we're going to set up a player class which is going to inherit publicly from the person class. Let's do that. We're going to put in our player. We're going to put in the header file. Let's say player, not person. And we're going to say player.h. We're going to put in a CPP file. We are going to hop over in the header of player and put in our class. Let's close the left sidebar here so that you can really see everything. We have an include guard in.
Okay, let's get our include guard. Let's get all of this information written in. Player H. Define player H. Include person.h. Okay, so we're going to do public inheritance from person. So we'll just include that note that he does here. We'll do public inheritance. I can't spell inheritance for some reason. From person. So we do class, player, public, person. This should be very similar to the one that we had before. So because this is the same, essentially the same idea that we had. Player, and then we go here. Okay. Public, player. Oops. So we have a default constructor and a destructor. Great. So we come here. See the access. We have two inherited members from person. Void play. I'm going to assume that we're going to define that somehow. Maybe not. I don't know. And then these are going to be our private member variables. So we have our int m career start year, and it initializes at 0. Double member called salary. And we're going to do 0.0. And then we have our int health factor, which I don't know what the fuck a health factor is supposed to be. So from 0 to 10, I assume that it's going to just be like some arbitrary, like how healthy is this person number. So this is our player class, which is inherited from which inherits the stuff that we have in person.
We have the class player declared. It is going to do public inheritance from person. And what this is
so
going
it's everything
to
a
do
person is
that
and more.
anything that is public in person is going to stay public in player. Anything that is protected is going to stay protected in player. And anything that is private is going to stay private. So we want to be able to access private data from a person object. For example, we can't access the address member variable here because it is private, but we can use the full name and the age from the derived class. Let's make sure we have a CPP file n before we try things out. So let's hop over to the CPP file and put in a possible implementation.
All right, let's go ahead and get all this information. Person.h, include player.h, include IOStream, player, in the scope of player, boom, 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 std ostream operator, std ostream out, const player, we're doing this, so out, player, full name, player dot get full names. We're calling our full name getter the method that we created with which we can get full names. We come here, we do age, and then we have our player dot get age, which is another getter, and then we have our address, and then our last getter, player dot get address, and we're closing this bracket like so, and then we're returning out, which from what the way this is written, I assume this is our, I don't know. This part of the reason I don't like this OStream operator is because I don't understand how to read it. And it's I think it's been explained, but I just don't understand. So I'll do player, and then we're getting our player destructor. And then we have boom.
We are going to include the person and the player because we're going to be using these, and we are going to set up a constructor which is not going to do anything for a player. We also have our output stream operator which is going to print the data. It is going to be using the getters we have in the base class, and we have access to them because we are doing public inheritance, so they are going to be public and we can call them from the outside like we are doing here. Notice that this is an outside player object and we are calling our public members on it, and this is going to work. We also have a destructor n, which is really not going to do anything, but we're going to keep it in here because it's not going to hurt. So now what we want to try out is to see if we can access things from the base class. The first thing we have in the base class is the full name, and I think we can actually copy these things, or we can just use them. M full name, M age, and M address. We're going to try and use them in the derived class. So let's try and say M full name and change the full name, for example, to be Daniel Gray or Jon Snow. And we're going to change the age to be 55. Why not? And we're going to try and access the address. Let's see what we called our address member variable. It is M address. We can grab that and use that in our class. If we're trying to access that, we're going to get a compiler error because that's going to be private to the base class. You notice that if we even try to put some junk data, we're going to have a squiggly line because this is not accessible here. And Visual Studio Code is going to say that this is not accessible because it is private to the base class. So we can access M full name because it was inherited as public. So this is going to be okay. We can use age because it was inherited as protected. We can use it in a derived class, but we can't use the address because it was inherited as private, and it is private to the base class. So this is not going to work. Even if we try to compile our code, we're going to get a compiler error. Let's try to do that so that you can really see for yourself. Okay, so we have a compiler error, and this was declared in the base class as private. This is what the compiler error is saying. So we shouldn't really be doing this. The derived class has no business modifying a private member of the base class. This is the message here.
That makes sense.
So we're going to comment this out and say that this is going to give you a compiler error. But we are also going to create a player object and try to access these guys and see how access is from the outside. So we're going to go in the main CPP file and we're going to include player.h, and we're going to create a player object. We can put in a separator and say a bunch of dashes here. This is going to do, I think this is going to work. And we're going to create a player object. We can say player and not put any parentheses here. This is going to call the default constructor that we have in our player class, and we can try to use this. But before we do, let's try and build and see that this is going to build just fine. We're going to build with GCC. Let's do that. We're going to see that the build is good. We can try and access stuff from this player object. We can say player and say M full name. You see that this is accessible. We can actually change this to Samuel Jackson. We can do that, but if we try
Samuel Jackson
MH, we're going to see that this is not accessible here because this was inherited as protected. If we go back to person, we're going to see that the age is protected, so it will be accessible in derived classes just like we did in our play method of the play.
Okay, let me see. So we're looking at our player. So I'm actually going to go ahead and comment this out because this isn't usable for us. But then if we look at person, so if we look here, our full name This is a public thing, so it's usable. But because because the age is protected, it's not. It's private outside the scope of the class. So this is no longer accessible. So we'll call it public. So we'll say public member variable. I don't even know what to say. Public member variable, changeable outside of usable outside of scope. Usable outside of class scope. And then this one is protected member variable. Private outside of class scope. So that makes sense. I'm actually going to go ahead and comment this out.
Player class, but we can't access the age from the outside of a player object because that's not going to be accessible from the outside. This is a defining feature of the protected access level. So this is not going to work. Even if we try to build, we're going to get a compiler error along the lines of this is not accessible in this context, and it was declared in the base class, so we can't really access it from the outside. This is the compiler error here. So we're going to comment this out and say that this is going to give you a compiler error. Okay, so I hope you know that you can't even have a chance accessing a private member of a base class from a derived object in the main function like we do here. So if we try and do player and say maddress, this is not going to work. Okay, so if we try to change this, for example, to some junk data, this is not going to work. We're going to get a compiler error because this was declared private in the base class, and it is private to the base class. You can't really access it from the outside. You can't even access it from a derived class, so let alone access this on the outside in the main function. So this is not going to work. It is going to give you a compiler error, but we're going to build and show you the compiler error because we are learning here. So we're going to get a compiler error that says maddress is private within the context where we are trying to use it. So we can't really use it from the outside here. Again, this is going to give us a compiler error. Let's say that here. And this is really what I wanted you to learn about public inheritance. Anything that is public in the base class is going to be public in the derived class. Anything that is protected is going to stay protected. And what that means, it will be usable in the derived class, but you can't use that from the outside. And anything that is private in the base class is going to stay private, so you can't use that from the derived class, and you can't even use that from the outside like we are doing in the main function here. This is not going to work. Okay, so now that we have this in place, we're going to set up another class that is going to do protected inheritance, and that's going to be our nurse class. So we're going to put this in. Let's put in a nurse header file. This is going to be nurse.h. We're also going to put in nurse.cpp.
Hold on, let me... Oh, I don't have the... I knew there was something that was missing with this. This one should be endif, right? Wait, do I not need that? What?
This is going to be nurse.h.
Alright, we're just going to go ahead and... nurse.h. And there's going to be nurse.cpp.
Also going to put in nurse.cpp. Okay, so we're going to head over in the header file and put in the code for our nurse class. We're going to say class nurse.
You just copied a bunch of stuff in again. Fuck. If and def nurse h, define nurse h, include person.h, which we wrote. So here we go. Nurse will do protected inheritance For some reason I can't spell that word. Class. Nurse. Protected person. Okay. So this is going to be different from the player class that we did where it inherited person publicly. Because what this is going to do, and this is going to be me repeating probably what he says a billion times. But when we go to person, what should happen when we inherit person protected like this, then all of these public variables, person, the constructor, the destructor, the getters, the public thing here. So the member variables specifically, I think, are the main key here. The full name will not be accessible outside of the scope of the class. Is kind of the way I'm understanding this. I'm hoping that it will. Yeah, because with player, when we inherited it publicly, so the full name suddenly becomes. We aren't able to. Oh God, words. We are not able to edit the full name without going through getters, essentially. But or we won't be able to, I don't think, because the because we were able to with the player thing before, I'm pretty sure. Oh God, I can't words good. Where's my goddamn? Where's my main? All the way over there. Got it. Yeah, so when we look at person here, we have this whole thing. We just do our constructor or whatever. But we can change the full name here in player, because as player it is totally it's accessible. If we were well, the way I'm understanding this, when we make this, it'll be nurse.m full name. We won't be able to change the nurse's name in this scope. We'd have to go into or go through getters to get to or we go through setters, not getters, for to change the name in the nurse's scope, because this will be a private. This will be a protected variable in this new thing that we're creating. All right, so let's continue. Let's continue with this. I need to make this fucking thing. Friend std ostream operator std ostream const nurse operand. That's a new word. I don't think we've seen that one done this way. Public nurse constructor nurse destructor void treat unwell person. Damn, bro's already at chapter 18. I don't know about already. I started this feels like a month ago. I'd have to see. When was my first C++ stream? Wasn't that long ago. But it was like 4 weeks maybe? 3-4 weeks. Alright, so we have our private int practice certificate ID. Just initialized at 0. And then we're just doing like this. And then we have our end if, oops, nurse h. Alright, anything insane in here that I'm not doing correctly? This. That's not correct. That one wasn't correct. This should be fine now. I don't understand this operand thing, but I'm gonna get the sense I'm not supposed to yet. But anyways, let's go. Alright, so this should be good.
To mean that we want to do protected inheritance. And what this is going to do, anything that is public in the base class is going to be protected in the derived class, which is our nurse class. Anything that is protected is going to stay protected. Anything that is private is going to stay private to the base class. This is what we mean here. Okay, now that we have this in, we can put in the implementation for our nurse class.
Oh boy, now we have to do the implementation. I swear I know how to speak. Include nurse.h. Include IOStream. For 4 weeks, this is not bad at all. Well, if you say so. I only have this experience to go off of. So I'm hoping that I can. Part of this is just that I don't know. I hope that I'm keeping this information as well as I'm hoping that I am. What I need to do is start doing like tests and shit. But because I think we did a couple of them, but they were harder than I anticipated, which I imagine is a result of me. Well, I think I was told I was binge watching the video. Full name. And then we have this. I really don't like this OStream thing, because it's not the way that I know how to write these things, and I don't understand how it works. Here we do page operand. Curious what operand is. Address operand dot get address practice certificate ID. And we have our operand dot practice certificate ID.
And we're going to have a constructor, and we're going to have our output stream operator, and we're going to have a destructor, which is really not going to do anything because we don't have any dynamic memory allocation in our class. We are going to try.
I really hope he shows off what that what the other end of that operand practice certificate ID thing. Really hoping. Because I don't know what the fuck that's supposed to look like. Alright, return out.
Try and build this code to see that it is going to work. We have a squiggly line in the main CPP file, but it was because
I need to see this. Get this wrong. And then we do like so. Alright.
Do anything because we don't have any dynamic memory allocation in our class. We are going to try and build this code to see that it is going to work. We have a squiggly line in the main CPP file, but it was because of the line 15 here and it has been commented out. Let's see if we can build this program. Okay, you see that the build is going to be good, and we are able to call thanks from our output stream operator. You see we have a nurse operand. We are able to call this get full name and get age member function because they are now protected in the nurse class, but we are able to call them from the outside because this operator is a friend of our nurse class here. I want you to say this.
See, he's explaining this friend thing that's been in here for a while. I have no idea what friend is.
Some of you are going to ask, aren't we using an object and calling a method using the dot operator? This qualifies as calling things from the outside. And yes, that's true. But this method is really like a member function in that it has access to private and protected data from our nurse class. And the reason is it is a friend of the nurse class here. That's why we are able to do something like this. But what I really want you to see now that that doubt is cleared is the kind of access we have to things from the base class. We will still be able to use mFullName here because it was inherited as protected. So we can use it from a derived class. We can say mFullName Jon Snow. This is going to work because this was inherited as protected. Now it is protected in the eyes of the nurse class. This is what we mean here. So this is okay. This is going to work. We can get the age. We can use that. And we can say John's. And we can say 23, for example. This is going to work because this is protected. But we can't use the address. If we do that, we won't be able to change it. We will get a compiler error because this is private to the base class. This is the same thing we saw in the last lecture. This is going to give us a compiler error if we try to build this program. Let's try and build it to really prove this. The build is going to be good without line 17 here, but if we uncomment it and try to build the program, let's do that. We are going to get a compiler error, and the compiler error is going to say, let's go up and see if we can get this message.
Private within this context. You can see it right there. It's a little bit small probably for you guys, but it is private within this context. That's an error that's probably the error that we've seen the most over the course of this, well, course. Private to person and not allowed. Private to person. Not allowed. Compiler error. Yeah, so we aren't able to change the address within the scope of nurse. We would need to go through setters in order to change it in that case.
It's going to say m address is private within this context where we are trying to use it, and that's line 17 of the nurse class. If we go there, we're going to find the offending line here. So we're going to comment this out and say that this is going to give us a compiler error. Okay, so you shouldn't do this. Now that we know things from the inside, let's see how things fare on the outside. We are going to hop over to the main CPP file and include our nurse class, and we're going to create a nurse object. We can go down and say stdc out, and we're going to put in our dashes, and we're going to create a nurse object. I think we have a default constructor for a nurse. We're going to say nurse1, and we're going to basically try and do the same things we did for the player object from the outside. If we try to access the full name, now it's not going to be accessible because it was inherited with protected access level. So if we do nurse and say mFullName, you're going to see that autocomplete is not here. This is a good sign that this is not accessible from this place. If we say Davy Jones, we're going to get a compiler error, and if we try to build, we're going to get a descriptive compiler error. At least I hope. So let's build. We're going to
Is it going to say private within this context again?
Errors, and if we go up, we're going to have our error. Nurse was not declared in this scope. Did you mean nurse 1? Yes, we meant nurse 1. Sorry for that. We're going to build again. Thank you, GCC, for pointing this out. We are going to get another kind
I made that mistake
error,
too. Whoops.
And if we look at our error here, we're going to see that mFullName is inaccessible within this context.
Ah, so not private within this scope, inaccessible within this context, which is similar but different. But basically, we aren't able to. The result is the same. Compiler error. Inaccessible within this context. private, or I should say protected variable in nurse class. That's a whole note that I just took. All right, let's see.
Because it
Instructor's
is a
trolling for real.
protected member of the nurse class now.
A
It
little
was
bit.
inherited as protected, and we can't access it from the outside. We can access that from the inside because it is protected, but if we try to access it from the outside, we're going to get a compiler error, and this is a defining feature of protected inheritance. Even things that were public in the base class are going to become protected in the derived class. So this is the message here, and this is going to give us a compiler error. Okay, so if we also try to access nurse1 and say age, this is also going to give us a compiler error. Let's try to put in an age here. Let's put in 51. You're going to see that we're going to get the same kind of error. Let's really try these things out and learn about every possible way we can set up these things. If we look at the error, we're going to see that age is protected within this context, so we can't really access it. So this is the compiler error we get. And I hope you know that if you try and
the address we still can't
you're
access.
going to get a compiler error because that's private to the base class. So we can't even use that from a derived class like nurse here. That's not going to work. Let's say that here we have a compiler error, and we're going to set up another class which is going to inherit privately and see how that works out. The class is going to be engineer. We're going to see that the error here goes away. So let's create our engineer class. We're going to put in a header.
Okay, hold on. I'm going to comment these out because they're just going to give me compiler errors. But it is interesting that you can see that this one, with player, you can see that this works here. But then when you go to nurse, you can see that, oh, it works here. This one will work here, but it doesn't work to do the address. Whereas the player, I think it was, you were able to do both of these. All right, you're able to do both of them for this one because this one is still protected, but it's accessible to player. This one is accessible. This one is accessible to nurse, but the name is now also protected, so you're not able to change the name outside of it. And for none of them are you able to change the address because the address, if we go to person, is the private variable, and will never be anything more, never be more accessible than private. So that one is still the way that it is. And then now we're going to go and create a third class, which is going to protect, or which is going to private everything. So that'll be funny. What did he say it was called? Engineer?
Header file. That's going to be our engineer.h. We are also going to put in engineer.cpp. Okay, so we're going to hop over to our header file and put in our engineer class.
Oh boy. All right. Time to do more copying. I think that these are online somewhere. But I kind of like writing stuff out at this point. I'm also a little bit stubborn. Oh, whoops, person.h. Put it in H. Engineer is doing private inheritance. I always want to put an E there for some reason, even though it's always wrong, no matter how many times I try to put it in there. Engineer private. Private. Privati. Pure soon. There we go. So, what this means for us is that everything that was public or protected in person is now private. And so we're not able to access any of it outside of the class. It's kind of the way I'm understanding that operator. I still don't really understand this friend thing. He explained it a little bit, but he did not go into extensive detail, and I think I probably need a whole class on it if I want to understand it. For now, I'm going to focus on trying to understand our inheritance class. Okay, so engineer operand. Okay, public. And we have engineer constructor, engineer destructor. I think he mentioned that we don't actually need the destructors because we're not doing anything with dynamic memory allocation, I think is what he said. I like doing them like that. And contract count initialize at 0. And then we have our end if engineer h. There we go. And it turns out I just need to spell engineer correctly in order for most of my errors to go away. Oh, this one needs that. There we go. Much better.
We're going to say engineer and say that we want to inherit privately from the person class. This is the syntax here. And this is going to do private inheritance. And what this means is that anything that is public is going to become private to this class. Anything that is protected in the base class is going to become private to this class. And anything that was private in the base class is going to stay private. We want to have access to that whatsoever in the derived class directly. We are going to hop over to the CPP file and put in our implementations. We're going to...
All right, let's look at our implementation. So obviously we need to include person.h because it is a person. We need to include engineer.h because it's the implementation of engineer. We need to include IOStream because we're going to be using stuff from that library. So we have our engineer in the context of engineer. Do like so. I don't know what the purpose of that stuff is, but it's there for a reason, I guess. All right, and then this is the thing that tells us how to print out this guy. So we have our ostream out const engineer operand, and from here we're doing out. Actually, it was like this, right? Out engineer, and this is all just text that we're trying to put into the terminal. Full name, and then we have our operand get full name. This is a getter, or this is the get part of the getter function. This is using the getter function that we established back in person. So then from here we go to age. We have our operand dot get age. Then we have our address operand dot get address. Contract count. We have our operand dot contract count. You know, actually seeing this, I need to actually edit something in nurse. No, didn't I? Oh, it would have been in nurse.cpp, I think. Yeah. We need to make this. I'm like 90% sure this is what I was missing. Yeah, okay, so back to engineer. So we come back here, and then we're returning turn out. We have our engineer. Whoops. This is the wrong one. Like so. This one has one too many E's. Oh, should probably. Okay, so it looks like this one, and it looks like this one, and it looks like this one. Look at that. We've got so many good things going on here. All right.
To have a default constructor for engineer, which is not going to be taking any parameter. We're going to have our output stream operator, which is going to still work because it is a friend of the engineer class. So all these things that were inherited to be private are going to be private to the engineer class. And any friend of the engineer class will have access to that. That's why we are able to call get full name, get age, and get address here, and get these things to work. Okay, now that this is out of the way, we can try and access our things. We're going to try and do the same things we did in our nurse header. We're going to copy the code because we are trying to access the same member variables.
Oh, yeah. This is fine. I'll just cut out the notes, I think. Actually, the notes are probably still the same, aren't they?
And we're going to see how this fares in our engineer class. This is going to save us a few seconds. If we try to access the full name, this is going to work because it is.
So we go into the build something. This here. So here,
private to this class. If we try to access the age, this is going to work because all these guys are now private to this class here. But if we try to access the address, this is going to give us a compiler error because address is private to the base class. Yep. If we go back to person, we're going to see that this is the case.
Yep, still
and
private.
If you try to inherit from this class in any way, you're not going to be able to change this access level. This member variable is always going to stay private to the base class, and no derived class will be able to modify or read from this in any way. So this is the setup we have here. If we try to build, we're going to get a compiler error. Let's first take this out and show you that this is going to build just fine without this line here. And I am going to build again and show you that if we bring that in, we're going to get a compiler error. So the build is good. We can go back in our engineer class and bring in the offending.
Uh-oh, I fucked something up. This is what I get for not building as I go. So project 49, header 1, unterminated if and def, player H. Supposed to do end if, player H. Uh-oh. Uh-oh. This is what I get. Okay, so we have our unterminated thing, which this should, if I'm not mistaken, this is just terminated with end if. So then we have our, in this one, main for expected a thing after definition in line 28. This thing. Oh, no. Hold on. In line included here. So in nurse H, expected a So we need this. Unqualified ID before string constant. All right, hold on. Let's try running this real quick. Oh, build finished successfully. Okay, well, we fixed our errors. Wow, I actually felt pretty smart there. Issues in file included from here. Well, that's not my file, so.
Line, we can uncomment this, and if we build, we're going to get a compiler error. Let's make sure you see the compiler error here. So
we're gonna go ahead and do like this. This should give us a compiler error. So we go terminal, run task. We're gonna, even though it has a compiler error, I want to make sure we see the same thing as he does. So we have our M address, we have our thing. In file included from engineer.cpp.
So the build was finished with errors, and if we go up, we're going to see that we have an error here. And the error is going to say
private within this context.
Is private within this context.
Wow.
And the context
Who'd have
is
guessed?
what we have at line 17 in the engineer class. So we can go there and find the offending line, and we're going to comment this out, and this is going to give us a compiler error. Now you know this. But this is how things are going to work from the inside. But we also need to look at how things fare from the outside. Let's go back in our main CPP file. We are going to include our...
You know what, let me actually make sure... let me make sure it builds properly again. Okay, build finished successfully. We know that it works. So all of this stuff is commented out.
Engineer
so
class,
we're gonna make,
and we are going to create an engineer object. We can go down and say stdc out and put in a bunch of dashes to separate our things.
Yeah, I'm just doing empty lines.
Create a engineer object, and that's going to be engineer 1. And if we try to access the full name, that's not going to work because it is now private to...
Did I misspell it? Engineer. Identifier engineer is undefined. Oh, I didn't include engineer. Silly me. Include engineer.h. And now this should be defined. I'm just calling it ng1 because that's easier for me.
The engineer class, if we say engineer1 and try to say m full name and try to change the name in any way and say, for example, Olivier Godson. I am making this up. I don't know if this name exists. But the point is that this is not going to work. It is going to give you a compiler error because m full name is now private to the engineer class. It was inherited to be private to the engineer class. And if you try to do this, you're going to get a compiler error. Let's try and build with GCC to really show you this. And the build is going to be finished with errors. And if we go up, we're going to find our error. Full name is inaccessible from within this context. And the offending line is at line 27 of the main CPP file. If we go there, we're going to find our line, and we're going to say that this is going to give us a compiler error. So let's say that. And we can't even access the age and the address member variables. The age is also going to be private to engineer, but the address is private to the base class. So that's not going to work either. So we can't really access that from the outside because it is now private to the engineer class. So
that makes perfect sense based on everything that we've heard so far from here. Because we have our full name. Because like with our person class, we fucking holy shit. We have like so many files now. So in our person thing, we had our public, our protected, and our private. And we showed that we can access the public one in the main because it's public, and so we could change the name, or Not change the name. We could change the name. We didn't do it for this one. We created a player class which inherits as public, or it inherits person publicly. I don't know exactly what the terminology is, but we use this kind of inheritance, public inheritance. So we're able to, in here, we can change the name, Samuel Jackson. We aren't able to change the age because in person, we have age is protected, so it's not accessible outside of the scope. Then we have our, and then our, of course, private, which is not accessible anywhere except inside of person. So that's true even of inherited stuff. So we're not able to. So like engineer, nurse, and player are not able to access address. That's only accessible here. Are you winning, son? I am winning. I am winning. I'm understanding. I'm still annoyed by this. Ooh. Ooh, excuse me. Sorry. You should never let anyone access your privates except your girlfriend. Too late. But yeah, so this, I'm still not understanding this or how we're doing this implementation. But this was not explained. This is just kind of, I think this is just here to be like a stand-in for, hey, we're focusing on something else right now. Because OStream, the way this syntax is done for printing out text is not something that we ever did before this lesson, and it was only briefly gone over, and I still don't really understand what a friend is, except that it somehow gives access to other stuff. But yeah. So anyways, we're winning. We're understanding the point of the lesson, I think.
Let's go down and really show you that. We're going to go down and say engineer one and say m age. If we try to do that, that's not going to work. That's going to give us a compiler error. And if we try to build, we're going to get a compiler error along the same lines as what we just got here. The build is going to finish with errors, and if we look at our error, we're going to see that m age is protected within this context, so we can't use it at line 28 of the main CPP file. This is going to give us a compiler error. Let's do that. We're going to say that here. And
inaccessible.
If we try and access the m address member variable, that's
inaccessible.
not also going to work because this is even more restricted for access. It is private to the base class, so we can't access it from a derived class directly.
Yep.
You can't even access that from the outside. So you should
only let Redbird access your privates. No.
Data here and try to build. This is going to give us a compiler error that says that this is not accessible from the main CPP file, like we are trying to do on line 29 here. So we're going to get an error, and the error is going to say m address is private within this context, and the offending line is at 29 of the main CPP file. We're going to take this out, and we're going to say that this is going to give us a compiler error. This is really all I wanted you to see in this lecture, and before we wrap this up, let's try and build again and make the error go away, because I don't like to leave you with code that has compiler errors and the build is good. And this is really all I wanted you to see in this lecture. That you can do all kinds of inheritances in your C++ code. You can do public inheritance, you can do protected inheritance, you can do private inheritance. And we had a chance to look at all these scenarios in this lecture here. The message is the same as we saw in the last
It's
lecture.
Exactly as you said, Gakwaya Sensei. It's exactly as you said.
Public and the base class is going to stay public.
If you inherit as public, then public stays public. If you inherit as protected, public becomes protected. If you inherit as private, public and protected both become private.
The private data from the base class is not going to be private to the derived class. It's going to stay private to the base class. So if you try to use this in any way from the derived class, you're going to get compiler errors because you can't access that, even if it is part of you. Player has a person part of it, but it can't access private members from the base class. You should really know this. We have seen that we can also do protected inheritance, and that's going to constrain things to have the highest level of access to be protected. So anything that is public is going to be stripped down to protected access. Anything that is protected is going to stay protected. Anything that is private is going to be private to the base class. You should really make this super clear. We can also do private.
I think it is. I think it makes perfect sense. Especially with the way we've messed with it today. Like, that's a lot of stuff that we've done, but it makes perfect sense.
Is going to be constrained to be private. Anything that is protected is going to be inherited as protected to the player class. But anything that was private in the base class is going to stay private to the base class. Even the player class won't have access to this member directly. If we really need access to private data from the base class, we might go through public getters or anything we get from the base class, but we can't access M3 directly and use it from the derived class. That's going to give us a compiler error. This is really all I wanted you to see in this lecture, and I hope you find this interesting. We are going to stop here in this lecture. In the next one, we're going to try and zoom in on private inheritance and show you some things you really need to be careful about. So go ahead and finish up here and meet me there.
All right, so that's closing in on private inheritance. How far along in this chapter are we? I'm kind of curious. Oh man, we're only at like the halfway mark apparently. Ooh, okay. This is going to, so I'm kind of getting the sense that inheritance is going to be like a whole week, and then polymorphism is probably going to be two more weeks on top of that. So I think I'm going to go ahead and call it here for today. This has been a lot of stuff, but hey, look at that. We made it over the 1 day mark, guys. We've been watching this video for more than 24 hours. Let's go ahead and open my file that has my progress on it. All right, so we're doing chapter 18. We're looking at 24 0007. Actually, it's not 00, is it? That's the wrong one. 240742. He did the thing, general jubilations. Inheritance is dense. I would have helped more if I wasn't being hilarious in the call with the boys. Fuck you. I would have helped more if I wasn't goofing off in class, you dickhead. No, it's fine though. It is extremely dense. Like, I mean, look how many fucking header files we have. Look how many fucking files we had to make just so that we could do really basic feeling inheritance stuff, right? Just to demonstrate how this works. You know, like it's kind of a lot, because here it's it's fairly thorough, I think, because we have like, okay, so obviously we aren't able to access the private member because it's private. We aren't able to access this one because it's protected, so it's private outside of the classes. But this one is public, so we can change it. And then here it's like, oh well, this one, it's because we inherited as protected, even though the base thing says that this one is even though the for base person this is public, for nurse it's considered private. And the same goes for age and address, which is private in the base class. So we still can't access that one. So if you want to edit those, you have to like look in the nurse header, or not the header, the implementation, was it? No, it was definitely in the header. Oh yeah. I'm just not able to read. So here we can edit the name because it's because that's inherited. It's protected, but it's part of the. It's still accessible to the nurse class. The age also is still protected, so it's accessible to the nurse class. So we go back to our main, and then we have our engineer. Engineer inherits everything as private. So then we have our. So then the name for engineers, private. You can't access them. So if you want to change anything with engineer, you have to go here, and you're able to change the full name and the age because it's accessible to engineer. But again, address, private to our base person class. so you can't access it outside of this. So I think it makes sense. I actually understand how I understand why we made so many files and how that all works. The only part of this that still annoys me is this friend shit. That's the thing that pisses me off. I don't understand this OStream fucking syntax because we haven't used it before this chapter. And it kind of came out of nowhere and blindsided me, and especially yesterday I was very very frustrated with how it all works because we haven't done it before. And I don't know what like I understand kind of what a friend is. Apparently uh it's like it's a friend of a given class. It's like, oh yeah, this is a friend of engineer, this is a friend of nurse, this is a friend of person, this is a friend of player. So I'm able to use these things even though it's kind of outside, but not really, but kind of. I'm not 100% on that whole thing. But the inheritance part, I do kind of understand how inheritance works fundamentally. So I'm gonna call this one uh, closing in on. Let's just fucking call it private inheritance. For some reason, I always want to call it inheritance, and that's not right. Rag really doesn't understand friends. You're right. I don't. I don't. That's why I left the call, so that I could do this shit. Because I needed to. Anyways, so that's quite a lot that we've done today. I think it's quite a lot that we've done. I mean, it's in only two. I mean, it's only been 2 hours, and we're like each yesterday and today we've only gotten through 40 minutes of the actual video, and I'm like fucking really. We did just this today, I think. Base class specifier zooming in. Yeah, no kidding, we're zooming in. We still have another 2.5 hours of inheritance to go, so look forward to that. We're going to be doing some more inheritance tomorrow. I'm going to go ahead and move over here. We're going to be doing some more inheritance tomorrow. It'll be hopefully as interesting then as it was today. This has been a hell of a video, but the fact that we're over the 24-hour mark means that we're in the final stretch. We're in the last 7 hours of the video, which means we got another like 20 hours of actual stream most likely. With how slowly I've been going through these last couple of chapters, but it is hopefully as interesting for you guys to watch as it is for me to try and puzzle these things out. So yeah. Anyways, guys, I'm gonna hop off. I'm gonna eat some food and all that good nonsense. You guys do the same. I'm gonna be playing some Tenchu later tonight. In like 6 hours or so. So that'll be then. I hope you guys have a good rest of your days, and later. Bye. Thanks for hanging out.